Okay, in this video, we're going to compute the Laplace transform of the function 3t, and we're going to use the definition. So the definition is you take the integral from 0 to infinity of e to the negative st times the function that you're computing the Laplace transform for. So we're going to plug in 3t, and it's with respect to t. So we need to use integration by parts because we have these two functions. You know, a substitution wouldn't work here. So we need to choose, say, u and dv. And you want u to be a function that will simplify, when you take the derivative. So I'm going to choose 3t. So when I take the derivative, it simplifies to a constant, 3 dt. That means dv is going to be the rest. That's going to be e to the negative st dt. And I need to find the antiderivative of that. So that would be negative 1 over s e to the negative st. And we're going to use our integration by parts formula. So it's uv, let me write it over here. So it's uv minus integral v du. So uv will be, let's say, negative 3 over s, 3t over s e to the negative st. And we have to integrate this from 0 to infinity. So we need to evaluate this part from 0 to infinity as well. And then minus integral 0 to infinity v du. So v du, it's going to be negative 3 over s e to the negative st dt. All right, so let's just simplify a little bit here. So I'm going to call this, say, negative 3t over s e to the negative st. So that'd be positive st. From 0 to infinity. And then I'm going to combine these two negatives together, so make a positive sign out front. And then 3 over s is a constant. I'm going to pull it out front. And then this integral here, we don't have to use integration by parts, we actually do use a substitution, but I think we all know the rule for the antiderivative of an exponential. So I will do that next. So we get negative 1 over s e to the negative st, and that is also evaluated from 0 to infinity. So let's figure out what to do with these with 0 to infinity. So when you plug in infinity, what you actually do is take a limit, right? So and this is with respect to t. So we're going to look at what happens when t goes to infinity. So if I plug in, or if I take the limit as t goes to infinity of the top and bottom here, we get infinity over infinity, right? So 3t would go to infinity, e to the st would go to infinity. So when that happens, we call that an indeterminate form. And if you remember from calculus, we would use L'Hopital's rule. So in L'Hopital's rule, you would take the derivative of the top and bottom and then evaluate the limit again. So just off to the side, what would the derivative of the top and bottom be? It'd be negative 3 over s squared e to the st. So when I take the limit as t goes to infinity now, I would get negative 3 over infinity. So that would mean that goes to 0. All right, so this first part, just the infinity part, I'll take the limit. This expression will go to 0. And if I plug in 0 for t in the numerator, that's going to be 0 as well. So this whole term here goes to 0. On the other side, e to the negative st to infinity, as t goes to infinity, that's going to go to 0. So let me write this down. That's going to go to 0. And then when you plug in 0, e to the 0 is 1. So I get minus negative 1 over s. So that's actually going to be plus 1 over s. So I get 3 over s squared. So that is my Laplace transform of 3t.